Hello guys, welcome to CodeStudio. In this session, we will try to perform exploratory data analysis and build the machine learning model to predict the term deposit subscription by the client in a bank. Okay, it will be a supervised machine learning, and this model will try to solve the classification problem, like whether the client will subscribe the term deposit in a bank or not. Okay, so let us go and download the dataset from the kaggle.com. So here is the URL to download the dataset. I'll update this URL in a description box. Okay. To download the dataset, now scroll down and you can click on this button. Okay. Before downloading, let us understand what is the data file and what are the columns it has. Just click on that. So basically, this is a classic marketing bank dataset. Okay, uploaded originally in a UCA machine learning repository. This dataset gives information about marketing campaign of any financial institutes, in which we have to analyze in order to find the ways to look for the future strategies in order to improve the future marketing campaigns for the bank. Okay, basically it is a marketing campaign data set which has these many columns or features, and the label that is our target column is deposit. Basically this data set is in describing like about the client education information. It's his loans and okay his balance, and when did the customer representative contacted the customer, the client, all those details. And based on that, okay, whether the client has shown the interested on term deposit or not. Okay, those values in form of yes or no it has given. Okay, now let us download this by clicking on this. So I have already downloaded the data set. Okay, now let us go to the Jupyter notebook and perform the exploratory data analysis. Okay, then after we'll also try to build the model. Okay, this section covers the the about the data file. Okay, from where I have downloaded this. Okay, now this section is telling like what is a term deposit. So basically a term deposit is a deposit that a bank or financial institutions offers with the fixed rates, often better than just opening a deposit account, in which your money will be returned back at the specific maturity time. Okay, for more information you can check this link. Now let us import the required libraries. Now let us try to understand the basic information about this data file. Okay, let me create a data frame. Check the data. Check the data frame structure. So you can what type of columns and how many columns are there. Now let's find the number of rows and columns. So basically it has around 11,000 plus rows and 17 columns. Okay, let us describe some numerical features. So basically these are these many numerical features we have, and these are the statistics about this for individual features. Okay, now let us understand the categorical features and its unique values. Okay, so basically we have these many categorical features and these are the unique values. Okay, so let us segregate and note down the features and labels. Okay, so basically this is about the data file. Now these are the these many features we have. Okay, some of are the numerical features, some of are the categorical features. So I had given all these numerical the categorical values as well. Okay, and the final one is the deposit. Okay, so basically age, one second, yeah. So basically we have a feature called age in years of the client. Okay, then job type. Okay, the type of the job of the client. So basically we have admin, technician, service management, all these the job types are given. Then after the client marital status, whether it is a married, single or divorced. Okay, and then his education background, like whether it's a secondary, tertiary or primary or unknown. Okay, similarly the default, whether he or she has a credit in the defaults or not, yes or no. Okay, and his balance. Okay, balance in account. So and the housing, whether the client has housing loan or not, yes or no. Okay, similarly the loan, that is a personal loan, whether it has a personal loan or not. The communication, like whether the okay, like in unknown cellular, the what mode the representative has tried to reach to the client, so cellular or telephone. Days, like last day, last contact day of week. Okay, like Monday, Tuesday, Wednesday, all this. Okay, month, basically last contacted month of the year, January, February, okay, till December. Okay, duration, the last call duration in seconds basically. Okay, then after the campaign, so number of contacts performed during this campaign for this client. Okay, similarly we have a periods, number of days that is passed with the passed by after the client was last contacted from the previous campaign, and we have a previous number of contacts performed before this campaign and for this client. Put outcome, that is the last feature in our given data set, that is the outcome of previous marketing campaign. So basically these were the features given in the data set, okay, and the label, that is a whether the client has the client that is a subscribed term deposit or not, okay. So the values will be in form of yes or no, okay. So that was about the data set details. Now let us perform the exploratory data analysis. So in this session we are going to perform following exploratory data analysis on following points, okay. Like first of all we'll try to find the unwanted columns, okay. Let's say if there is an ID sequence or serial numbers are there, okay, those. Then after we'll try to find the missing values, okay. If there is any missing values, then we'll try to find out the relation with missing values with the target variable. And also now we will find the features with the one value, because if there is only one value it has, then there is no use of to have those kind of features in the data set. And then next we will try to explore the categorical features. Now we'll find the categorical feature distributions, and also we'll see the relation between the categorical features and the labels, okay. Once we're done with the categorical feature, we'll try to explore the numerical features. So these also could be discrete and continuous. So first we will find the discrete numerical features, then after a relation between discrete numerical features and the labels, then after we'll find the continuous numerical features, and its distributions, its relation with the label. Then finally, okay, we'll try to find the outliers, correlation between numerical features, find the pair plot, check the data set whether it is a balance or not, okay, on target values in the classification, okay. So let us begin now. So first point, that is a find unwanted column. So in our given data set, okay, basically there is no unwanted column, okay. So that's why I take a note away. So I just noted down the takeaway. So there is an unwanted column present in the given set. Now the second point is to find the missing values. To find the missing values, this is the code, okay. Just run this. So here is the output, no missing values found. So I just noted down the takeaway, that is no missing values found, okay. Now the third one is a find features with one value. To find the features with the unique values, here is the code, okay. So check with the value 1. So we do not see any 1, okay. So then I have noted down the takeaway, that is a no feature with only one value, okay. Now fourth point is explore the categorical features. To find the categorical features, basically what we are trying to do, we are writing a comprehensive list, okay, where we are trying to find the only the features which has a data type start with O, okay, and that and the and the column is not of deposit, that is our target feature, target column, okay. Let me run this, okay. So these are the categorical features. Now let's try to understand the unique values of these categorical features. So these are the unique values of each individual categorical feature. So here is my takeaway from this section. So there are 9 categorical feature. Feature job and month has highest number of categorical features, right? Okay. Now the fifth point is to find the categorical feature distribution. So to find the distribution of categorical feature, here is the syntax, where I'm iterating the categorical feature of a previous section, okay, and I'm trying to plot the count plot using a Seaborn library, okay. So let me run this. So here is the graph of this, okay, the categorical features distribution. As for these graphs, okay, I'm taking the noting down the takeaways, okay, out of these graphs. So from this job feature, basically we could see the management, the client with the job type is management, okay, those number of records are high in the given data set. Similarly, for the marital features, the client who married are contacted high. Similarly, for education, the person with say, the secondary education are more in this given data set. Okay, so likewise, I had taken the other the takeaways also. Like the client with job of management record are high in the given data set. Client who married are high. The client whose education background is secondary are high. Default feature seems to be does not play important role, as it has values of no at high ratio to the value yes, which can be dropped in the feature engineering. Okay, and the data in month of May is high and less in the December. Okay, now sixth point, that is a relation between categorical feature and the label. So here is the syntax for that. Basically we're trying to plot the cat plot, okay, or against individual categorical features with respect to the our target value column. Also let me draw or analyze in a numerical form. Okay, so basically here is the data. So these are my takeaway from given section. Okay, so first this the retired client has high interest on deposit. Okay, so from this you can see the retired employee. Okay, the representative tried to reach 262 retired employees. Okay, who said no in the deposit terms deposit, whereas representative reached to the 516 retired employees who said yes. Okay, it means the ratio is high at the yes level for retired employee, right? Similarly from the graph also you can see there's a second point, that is the client who has a housing loan seems to be not interested much on the deposits. See, you can see here, no housing loan. If the housing loan in yes, okay, then they're not interested in deposits. Okay, similarly for personal loan. Likewise, I noted down the takeaways also. Like in month of March, September, and October, and December, clients show high interest to deposit. In month of May, records are high, but the client interest ratio is very less. So let us understand. Yeah, basically, this is the graph. Okay, and numerical also we can validate that. Like in October, September. Okay, the client who reached okay, uh, they shown the high interest on deposit. Okay. Now let us explore the numerical features. So basically we have a 7 features. Okay, these are the numerical features. Now let us try to find the discrete features. Basically we will have two types of the numerical features. One would be discrete and another would be continuous. So for a discrete, the features which is having a unique values of less than 20, we will treat it as a discrete. Okay, for that I'm running this. So there is no discrete feature. Now let us try to find the continuous features. Okay, so there are 7 continuous features. Let us see the distribution. So to see the distribution of the continuous features, basically like I'm iterating the loop on the continuous features. Okay, and I'm plotting the distribution plot using a Seaborn library. Okay, so these are the plots. So it seems like this one days these are normally distributed, whereas these balance, duration, campaign, p days, all these are skewed towards left, right? And it seems like as per this, it seems like it has some outliers also. Now let us understand the relation between the continuous numerical features and the label. So for that I have drawn the box plot, okay, using Seaborn library. So from this box plot you can understand like the age, okay, who is having a older age or younger age are are showing interest on the term deposit. Similarly for a duration also, like the person who contact for a longer duration, okay, those seems to be showing the interest. Okay. Now let us try to find out the numerical feature. Find the outliers in a numerical feature. So to find the outliers in numerical features, we have to plot the box plot. Okay, using a Seaborn library. Okay, here is the command for that. Let us run. Okay, here is the box plot for individual the numerical features. So basically age. See, you can see these are the outliers. Okay. So these many columns seems to be having outliers. Now in feature engineering, we'll try to analyze more and try to reduce these outliers, or try to remove the outliers. Okay. So this is my takeaway. Now let us understand and explore the correlation between these numerical features. So basically these are the numerical features. It seems like there's no feature is heavily correlated with each other. So that is what my outcome. Now let us try to understand whether the given data set is balanced with respect to the target value or not. Let us run this. So basically I'm trying to plot the count plot, okay, for target column deposit, okay, using Seaborn library. So it seems like there's a slight difference is there. Okay, it seems to be balanced. So let us understand by checking the numbers. Okay, so with no we have around 5,873, and with yes we have 500 to 5,289 dollars. So it seems to be balanced. Okay, so that's all about the exploratory data analysis on a given data set, guys. So now let us perform the feature engineering. In feature engineering, we are going to perform these many steps. Okay, so drop unwanted features, handle missing values, handle categorical features, handle feature scalings, remove outliers. So we'll try to understand it if we have anything to to perform on this. Okay, so as per the exploratory data analysis, we found like there is no missing values, no feature found with a one value, 9 categorical feature we found. Default feature does not play important role, so that can be removed. And it seems some of the outliers we found in these many features, right? Let us create a new data frame by using copy command. Okay, let us see this. Let us see the shape also. So default feature does not play important role, so this can be removed. So okay, before removing or dropping this, let us try to understand the count. Okay, so using this group by, okay, with respect to the deposit, let us understand the count. It seems like, out of 11,000 rows, around more than 10,000, okay, rows are having the default value as no. Okay, it means more than 95%, it has the default feature has a value as no. Okay, so that's why we're removing this, because it does not play an important role in building the while building the model. Let us drop this. So here is a command to drop. Okay, now let us try to remove the outliers. Okay, for that we'll start from the p days. So basically p days have -1 with these values, which does not have any significant meaning. Okay, and it's around 40%. So let us drop this as well. Okay, now let us try to understand the age. From the age, you can see it starts from the 18 and ends with the 95. So which could be common, I guess. So what we will do, will not drop or will not remove any outliers from this. Okay, age. And now similarly, let us understand the balance also. So basically, in negative, the balance are this. Okay, and in the positive, that is a high value, we have around these values. Okay, but you can see one thing, right? The person who has a negative balance, okay, and it seems like those are not interested, but the person who has a high balance seems to be are interested in the term deposit, right? So what we will do, will not remove the outliers and we'll keep this as is. Okay, now let us try to understand the duration. So here also the same, like the duration less, okay, the person also not showing the interest. Okay, if the duration is high, those clients are showing the interest on the term deposit. So we'll not remove the any outliers from this feature as well. Now let us understand the campaign. Now let us understand. So for no deposit, we have campaign of this till, and for yes, 32. Okay, so here also after 32, we have a high difference between these values, right? After 43, direct 63, and we have very limited rows. So what we can assume, we can assume these as outliers and we'll remove that. Okay. So what I'll do, I'll try to treat the campaign numbers, okay, which is greater than 33 will be treated as an outlier. Okay, and it should get removed. Okay, for that, here is the command. So I'm trying to remove the outliers and creating a new data frame excluding the outliers. Okay, see, those got removed now. Similarly, in let us see the previous outcome. Here also, we are assuming, after 31, okay, the remaining previous values are treated as outlier. Okay, and I'm removing that. So here is the command. Now we'll handle the categorical features. Okay, basically we have these many categorical features. Okay, whereas these three features, I mean they deposit the target variable, these are the the features, okay, which are having values as a yes or no, means the the binary classification, also boolean values, right? And even the deposit also. Or to handle this, okay, I am using this code, okay, where it will try to find the yes. If it is yes, then it is returning a 1, or else it is no, that is a 0. Okay, for other categorical features, I'm trying to use a or the get dummies method to convert these categorical features into a numerical features. Okay, so let us run this code. Then after this code, now let us see the new data frame. You can see right now all the features got converted. Now I can see all the number values. So now we are done with the feature engineering stuff. Now we will try to split the training data, I mean the data set, into training and test set. Okay, let us check the count of the training set and test set. Okay, so basically we have around 9,000 rows in a training set and around 2,200 rows in test set. Now before building a model, what we will do, we'll try to perform model selection techniques. Okay, so basically here we will take two algorithms, that is a random forest and an XGB classifier, that is XGB square classifier. Okay, and we'll try to apply model selection technique on these two the algorithms or classifier, and we'll try to find which algorithm gives the best score. Okay, first model selection technique, what we will use the k-fold cross validation technique. Okay, where it will slice the the data set into 5 slices. Okay, and it will give the 5 scores. Okay, out of those 5 scores we will get the mean and we'll try to find the best score. Okay, let me initialize this. Now let me run this. So basically these are the 5 scores for a 5 slice of data set. Okay, and the mean value is 85%. Similarly we will perform the cross validation on the XGB. So after applying a cross validation we find the 5 scores. Okay, and the mean value is 85%. Now to get the best parameters, okay, we perform hyperparameter technique using grid search CV for these two classifiers. In generally we don't perform this cross validation. We directly can jump into the the grid search CV approach, that is in defining these parameters with by passing this random parameter values for each algorithm. Okay, and pass this dictionary parameter to the this piece of code. Okay, that is in grid search CV method. Okay, which gives the best score and the best hyperparameters for the particular model. But the grid search CV takes time, so that's why I did this. I used the cross validations to quickly get the score of these models. I'm not going to run this grid search CV code. Okay, you can run it in your example. Okay, because it takes time. Okay, I already have the the optimized parameters with me. Basically, as per the the cross validation, we find like the XGB boost, XGB classifier gives the best score. Okay, so we are using this. Okay, and based on the using this model, we will build the based on this algorithm, we will build the model. Okay, okay. So here is the syntax to initialize the model, and let me fit this model. Okay, using fit method by passing the training set. Okay, so it's been trained now. Now let us try to understand the score of this model by passing the test set and evaluate this. Okay, now using this model, now we can find the the feature importance. Okay, so here is the code. Let me run this. Okay, so these are the important features. Okay, now let us run the confusion matrix to evaluate the model once again. Let me plot this confusion matrix in a heat map. Basically this is true negative and it is a false negative, and this is false positive and it's a true positive. So like this we can evaluate the model. So that's all guys for today's session. If you like this video, please like, share and subscribe my channel. Thank you so much.